This is IAT355 lecture 11.3, temporal visualization. We'll now talk about cycles. As I said in the first lecture segment of this small lecture series, many of phenomena that we are interested in, know about, operate on a cycle. So the cycles of the day, the cycles of the week, the cycles of the month, be it lunar or calendar month, and the cycles of the year. Those are fundamental to the way we live, and visualizations ought to depict that as well. So, typically, one of the ways to deal with the cyclical nature of a timeline of some phenomenon is to depict that cyclical phenomena in a cyclical manner. So here is a couple of weather visualizations that are to do with the cycles of, on the left, the cycles of the year. So here is the weather in Toronto and the weather in Washington, D.C., and that's from weatherradials.com. These things were plotted, and those plots are essentially stored as images on that website, so it's not interactive at the moment. But anyway, so what's being depicted here are the events throughout, say, Toronto's weather for the year. So there was an ice storm at this location, and it's depicting that event. The weather. The temperature was hovering around 0 Celsius, lots of ice on the road, stay home during one of those. One of the things, if you're not aware of this, you get an ice storm, and what it starts doing, if the ice gets thick enough, is ice gets all over everything. It's an amazing thing to see, but what it does also is ice gets so heavy that it, takes down power lines, and so significant ice storms result in power failures, and it's a big problem. And so what is being depicted, of course, around here is, the calendar year. And, so that starts with January and runs clockwise. Okay. And the radius, the distance from the center, is the temperature, starting with a very strong negative value, in this case, minus 20 Celsius. And that's about 0 here. Okay. And the color of the bars being depicted here is indicative of what the weather, the sort of the temperature range throughout that day. And so we're showing each of the individual marks are days being drawn in here. So what this is doing, of course, is depicting, the seasons of Toronto and Washington, D.C. You can see Washington has a much longer period of warm weather, particularly in July and August. Washington, Virginia, Maryland, can get to be pretty hot and muggy. It's hot and muggy in Ontario because of the proximity of the lakes, but as you go further south, it gets, hotter and more humid. And anyway, so these are kind of decent depictions of what the weather is like throughout the year. On the right, this is showing the daily temperature for an individual city, once again, except this is Beirut. And what's being shown here is a visual summary of, what the weather is going to be like throughout the day. And you can see that this dial just sort of turns according to the time of day, basically where the hour hand would be in a clock. And it goes, and this is a 12-hour clock. You have an option to choose, a 24-hour clock down here. Okay, so that depiction is not the only radial thing we've ever seen. So this is, you recall from lecture number 1, I showed historical examples. This is another rendering of the same idea. This is once again showing the course of events throughout the year. In this case, this was in 1854, and it's April 1854 to March 1855, the Crimean War. This is showing the number of people who are dying and what the causes of. And blue is battle, the thing you expect from war, people getting shot at, etc. But what Florence Nightingale's observation is it's not just people, men dying in the field that's the problem. They're also dying in the hospital, and they're dying in the hospital from infections, from infectious diseases. And this is at a time when the germ theory of disease was not widely accepted, or perhaps not even accepted very much at all. And Nightingale's innovation was to introduce sanitary measures, washing your hands, putting on clean clothes, making sure that human waste was dealt with appropriately and safely. This long list of concerns that up to that time were not understood, because there was the theory about how diseases was caused turned out not to be right. In any case, this is an illustration of the problem, where there wasn't much happening until about June, and then there was very significant increases, particularly during January of the following year, 1855, where people were men were dying much more commonly in the hospital, dying of the hospital than necessarily triggered by a wound or something, not just dying of wounds directly. And so this is part of her suite of visualizations that she put together to depict the cause and the effect of her introducing those sanitary measures, and once again drawn on the year for you to understand how the thing works. Here's another radial layout. This one is to depict things on a spiral. The advantage of depicting things on a spiral is you can have multiple periods depicted on the same visualization. And so in this spiral, this runs for about 3 years. Let's make sure we're clicking here. 1 year, second year, third year, from 2004 to 2007. And once again, this is a temperature graph. This is the temperature here's the legend here, the temperature in Rostock, where presumably the researchers, the people who developed this application, are working. And it's showing the trends in temperature. And so clearly this is winter time and this is summertime. And you can see the temperature key down here. And occasionally some winters are a little colder than others. So here's an example of the third year that they're depicting. The start of the year there was a cold snap in Rostock. So the spiral layout and the circular layout, the reason to use circular layout for cyclical data is it naturally and directly appeals to our understanding of cycle as a circle. The words are related and the concepts are, of course, related. Typically, in many of those displays that I've shown, what this center region is used for in those previous displays is, for annotation and label information and things like that. This thing is a system developed by Tamara Munzner and her colleagues at UBC. The name of the thing is Circos, and what it does is it uses circular layout of genes on a genome, and the purpose of the circular layout is to enable the central region to be used for depicting connectivity information, and that's what's shown here. The other thing that biologists do often, but not exclusively, is they also depict gene layouts without taking advantage of the switch box in the center. They lay out genomes circularly sometimes, so this circular layout sort of naturally fits with the user community of a visualization like this. In any case, so what this thing is doing is depicting a number of genes along a genome. Typically, the starting point is at 12 o'clock, and you read it clockwise as usual. And this is indicating where on the genome what nucleotide number you're at. And these things would be well defined once the genome has been sequenced, once all the DNA has been put through a sequencing machine and all the DNA letters have been located. That's interpreted to find out where genes are, and to find what the genes encode for, and that's being shown here in these outer rings. And what information that follows from that is what is known about what genes express what proteins, and what those proteins, how they interact with each other. And so that's what's being depicted to some degree in this central region. So there's a gene here that has something that many of the other genes interact with. And there's another sort of primarily focused gene here that expresses some protein that interacts with the rest of the system in some way. The point is that this circular layout affords the possibility of seeing all the context around the outside and how the interaction pattern occurs in the center. But my point is that the circular layout has this advantage with the central region, enables you to do more analysis, in this case, see connectivity. Okay, so that it wraps it up for timeline depictions of cycles. I recognize that the genome thing is not a timeline, but it has a similar kind of linear indexing that can sensibly put in a circle. And so I just thought I'd show it there as, if indeed there was some aspect of things happening throughout the year and you wanted to depict connectivity of events in January to events in June, or things occurring in each of those years, then you could use that linkage switch box idea in that context as well.